when we talk about normal force, so let me erase all this. So when we're talking about normal force, this is a force due to the elasticity of an object, and it's a resistive force. So it's only going to push, or I guess you can think of it as pulling, but it's only going to push as much as the object needs to. So if you are sitting in your chair at home watching this video, you have all the particles in your chair preventing you from falling. There's got to be something that is fighting you. So if we were to diagram this, we have the force of gravity acting downward, and the force due to the chair keeping you from falling, keeping you there in like an equilibrium. So we call that the normal force. And essentially what's happening, if you think of like the chemicals that make up the chair, the molecular bonds are kind of acting like springs. When you sit on the chair, even though if it's like a wooden chair, even though it doesn't look like it's compressing, it's still going on. I don't know why that atom got smaller, but those particles compress and they want to pop back to the distance that they're happy at. Or at least that's one way to kind of think of what's going on. So there's an elasticity to the whatever we're touching that wants to resist that compression. And we call it the normal force, not because it's typical and an everyday thing, but normal is a synonym for perpendicular. So it is always perpendicular to the surface that we are pressing on. So if you imagine like a wall and you are leaning against the wall, the force, the normal force provided by the wall, is not directed against the angle that you're leaning. It's actually just perpendicular to the wall. Now, the reason why I'm bringing this up with gravity is because when we're talking weight has kind of two trains of thought, and I think the problem is in physics we have specific definitions for things, whereas in everyday life we have kind of lax definitions. So when we're talking about weight, this could be the sensation you feel due to having the contact force on you. So when we talk about being weightless, like maybe you're in a roller coaster, and judging by the curvature, this is probably a dangerous one. Let's say you go over the hill too fast and you kind of leave your seat. Well, when you're not touching the seat, that normal force is gone, and we're used to experiencing that normal force. So that's what gives us that weightless feeling. So when we say we're weightless, we mean there's no normal force on us, because there's always some sort of gravitational force. Remember, every mass or every energy pulls on everything else around it that is a mass or energy. So there's always some gravitational force due to the Earth that we're experiencing. The weightlessness comes from not having that normal force on us. And let me redraw that arrow. Remember, gravity is always directed downward from our frame of reference. So that's what we mean by weightless. It's not that you don't have a gravitational pull, it's just that there's no normal force acting on you. So if we define weight as experiencing that normal force, that's what we mean by weightless. If we define weight as the gravitational pull, you're never really weightless. if you've ever sat on, not sat, but if you ever like stood on a bathroom scale, like, I don't know, maybe you're in wrestling or something, that machine, that device does not know how hard gravity is pulling on you. All it knows is how hard you're compressing it. Like some scales are simply just like a torsion spring that, or not torsion spring, but it's just a spring scale that when you get on it, the spring compresses, and judging by how much it's compressed, we can figure out how hard gravity is pulling on you. So it's not really measuring your gravitational pull, or rather the Earth's gravitational pull on you. It's measuring the normal force you're applying. And so that's why if you lean against the side of a wall, if you're leaning up against the counter while you're on that bathroom scale, or maybe you're a wrestler and you are weighing in, somebody tries to prank you by putting their foot on the scale, that scale reading is going to change because you're not putting your full body onto the scale if you're leaning on the counter, or it's not going to read your correct weight because you have somebody else pushing down on it. Bathroom scales, those spring scales only know how hard they're being compressed, so they're just giving you the normal force. So just be careful there.